Okay, well, we've talked about the left cosets and the right cosets. We've talked about the left and the right cosets. And we've not really linked them together. We've got a whole bunch of reasoning that applies to left cosets and a whole bunch of reasoning that applies to right cosets. We know that the left cosets and the right cosets are all the same size, but we don't really know what they look like. I'm just going to show you what they might look like here. So there's my group, and I'm going to use blue for left cosets. And the left cosets might look like this. They're supposed to be all the same size, but I'm not doing very well at illustrating this, am I? I'm not a very good artist. Okay, and so what do the right cosets look like? Well, there's the same number of them, and therefore they're the same size, but they don't necessarily overlap. The red cosets might look like this. They could look like anything. They could look like wibbly wobbly lines and overlap, and maybe not. They might overlap somewhere and then might do that. One of them might be the same. Oh, in fact, one of them is the same, of course, and you can figure out which one that is yourself. This is a rather big, I'm going to do that. So the red ones are the right cosets. Yeah, one of them overlaps exactly. This one's supposed to be matching over exactly, but I couldn't draw it properly. So in general, I'll go back to black. In general, left and right cosets are different. And this is kind of, well, I won't say weird, but odd. No, odd's the wrong word. Wouldn't it be nice if they were the same? Wouldn't it be nice if the left cosets and the right cosets overlapped, and so your graph would look like this, if I can draw it in this sort of stylized way. So the red, I'll just draw a simple one. So there's the blue one for the, which one was that? That was the left cosets. I'll draw the right cosets. Wouldn't it be nice? Wouldn't it be nice if the divisions between the left cosets were equal to the divisions between the right cosets? And this is quite an interesting idea, a very fruitful idea in group theory. It's so nice when this happens that you say if a subgroup has this nice property, put nice in scare quotes, property, specifically that the left cosets equal the right cosets, we say that this subgroup is normal. And we write it like this. We write it like, we say N is a normal subgroup of G, and we write it like this. We go N, it's sort of a less than, but with a sort of closed off. It's sort of a triangle like that. That's how we write it. And a normal subgroup is a really crucially important area of mathematics, in group theory at least. In the same way that when we've identified a homomorphism, we can use the homomorphism to learn lots about the structure of the group simply by identifying mappings from the group which might be unfamiliar to us to a group that's much more familiar that we can study, and we can see that there's reflections of the structure of the simple group in the more complicated group. We can use homomorphisms to understand group structure. We can use normal subgroups to get a much more clear and much more profound understanding of the structure of a complicated group. So I'm going to spend quite a long time talking about normal subgroups. I'm going to give you loads of examples. I'm going to try and explain why it's interesting. And hopefully I'll show you that you can use the notion of normal subgroup to classify groups, or at least I'll hope to introduce you to some of the flavour of that. Okay, I'm going to stop there. A normal subgroup is one whose cosets, left and right cosets, are the same. Just a normal, in general, subgroups are messy and difficult to understand because the left cosets and the right cosets don't overlap. That's the usual case. But if you can find a normal subgroup, then you can learn an enormous amount about the structure of your group. And I'm going to stop there.